Hello, and welcome to today's session on developing questionnaires. Please make sure, as always, that before we begin, you've got the PowerPoint lecture notes printed in front of you so that you can take down notes as we go through the presentation. Today, we'll be talking about developing questionnaires, and then we'll also reserve some time in class for having an in-class exercise on developing questionnaires where we will attempt to work in small groups and apply some of the skills that we learned in today's presentation. So let's start by defining what we mean by a questionnaire. We can define a questionnaire as a written set of items that are asked of every respondent in the study. And we can distinguish between different kinds of items that we might have on our questionnaire. One variety is closed-ended. In a closed-ended item, we have a fixed number of possible responses. For example, we might ask about somebody's experience at Denison, and the particular item might say something like, tell us about your experience at Denison on a scale from 1 through 7. And they would have to say that they very much enjoyed it or very much did not enjoy their experience at Denison. And they would have those 7 options, maybe numerals 1 through 7. Okay? That would be a closed-ended possibility because there are just fixed response options. Another one might be something like, would you describe your experience at Denison as relatively positive or relatively negative? And they have those 2 response options, relatively positive or relatively negative. We can contrast that with an open-ended kind of response where there isn't a fixed number of response options. Okay? An open-ended item might be something like, tell us about your experiences at Denison. Okay? And they can go any way they want with that. Now, an important point to consider is that if you give them an open-ended item, it might be the case that they will ramble for a bit, and in that rambling there might be some really rich information, or there might not be. So you'd have to come up with some kind of scheme for pulling out the themes, maybe, from the highly qualitative responses that you get from open-ended items. Nevertheless, those can be a terrific source of information when you're conducting some kind of survey research. Okay, we can also remind ourselves that these questionnaires might differ along a separate dimension, and they might differ with respect to whether they are self-administered or whether they are interviewer-administered. So it might be the case that we have a paper and pencil questionnaire, and people can complete these on their own. We can take that paper and pencil questionnaire and convert it into something electronically and deliver it through the web, deliver it through Twitter, deliver it through email or what have you. By contrast, we can have an in-person interview, and we're administering the questionnaire that way. It might be the case that we're doing this live and in person. You can even think of this as being done over the phone or maybe by Skype, something along these lines. So we can either have interviewer-administered, self-administered, and then any given item can be either closed-ended or open-ended. And we might think about what the pros and cons of each of those would be before we engage in our questionnaire research. Okay, let's talk a little bit about some other possible challenges that people encounter when they're doing questionnaire-based research. Caution is needed to achieve accuracy and precision when defining variables. So sometimes you and your research collaborators will have a very precise idea about what you mean by a construct like race or ethnicity. But in our everyday lives, we frequently conflate those two, and we might use terms like Hispanic and Latino interchangeably. I know that I myself will occasionally use those terms interchangeably, even though I've been trained to realize that many researchers make a distinction. So it might be the case that you would define Hispanic as a Spanish-speaking ethnic group, and here this would be an ethnicity. By contrast, we might say that Latino refers to people originating from North or South America, outside of the US or Canada. And we would typically think of this as a racial designation, not an ethnic designation. Now, we can say that a person having European Spanish heritage is Hispanic, and that's because that person would be Spanish-speaking, but Caucasian, not Latino, because Spain would be part of Europe. Okay, so we might want to get very precise in issues that seem very, very straightforward. Variables like race and ethnicity, sometimes you really do want to make a distinction, and you need to somehow communicate very clearly to your respondent what those possibilities are if in fact you want to push this distinction between ethnicity and race. Okay, let's move on to other factors that we typically consider on questionnaires. It is often the case that we use a Likert scale, and we're going to talk a little bit about some of the different ways that you might implement a Likert scale. This was originally developed by Likert, who I consider to be one of my homeboys of sorts, because he was educated at Columbia University long before I was. Columbia is one of my own alma maters. And he went on to found the University of Michigan's Institute for Social Research, which is a world-renowned institute for social research. And he was its director from 1946 to 1970. He gave us the scale that you might know that ranges from, say, 1 to 7 or 1 to 5, and usually those numbers correspond to a continuum that might stretch from something like we strongly agree with the item to we strongly disagree, and varying shades of gray, so to speak, in between. One of the things we might want to be very aware of whenever we're using any kind of Likert scale would be a central tendency bias. So we can define this as respondents may avoid the extreme response categories, or the case in which respondents are avoiding the extreme categories. So frequently, if you give people a 7-point scale, many of them will tend toward the center just because they don't want to offer extreme scores one way or the next. And a difficulty here is that people might have a slight inclination to lean one way or another, but they are maybe disinclined to express that. They have a bias toward the center. So there might be a slight polarization of the responses, truly, but when they go to actually fill out your questionnaire, they give you a neutral response, a bias toward the center of the scale. So to ensure participants demonstrate polarity, that is, to ensure that they're leaning one way or the next, we can remove the neutral response option from the center of the scale. Okay? So we can now basically force them into responding at least slightly this way or that way of center by removing the neutrality option that otherwise would have been in the center. So an even number of response categories can force polarity, as we say. And when we're talking about polarity, we're talking about having different valences, something more positive versus something more negative. Okay? So on the other hand, if we choose to allow some neutral option, you might want to leave that as a possibility, then you can have an odd number of items on your Likert scale. And the centralmost item there would, of course, be the neutral item. So you need to think about that in advance. Do you really want to push the respondent toward showing at least some kind of inclination, positively or negatively, or do you really want to give them the option of expressing neutrality? There isn't a correct or incorrect answer to that choice, but you as an informed developer of questionnaires should think that through and make a decision about whether you want to force them one way or the next, or whether you want to give them a possibility for neutrality. So the central tendency bias is one kind of bias. There's another kind of bias that we might talk about, and that's the social desirability bias. Respondents may portray themselves or their group in a favorable way. This is the social desirability bias. And there's some interesting anecdotes here that I'll try to summarize briefly. When I was in graduate school, some of the folks I worked with included Joachim Kruger and Russell Clement, and they did some really interesting work experimentally manipulating in-group and out-group differences. And here's how they went about doing that, really quite clever. They had people come in and work on a small computer answering some questions that were very much like the questions that we're talking about now in a questionnaire. And these were some simple demographic information questions. They were questions about personality. And after a few of these questions, the computer would assign a phony designation to these folks as either being grinders or grounders. Grinders and grounders are totally fictitious groups. They don't really exist. And the computer would tell the participant that based on their responses, they are either grinders or grounders. And what's interesting about that is, of course, this is a bogus set of questions up front. The computer is randomly assigning you to these bogus groups. Okay? Now what happens is, as the computer proceeds in the questionnaire, students are asked questions about how socially desirable their group is. And let's pretend that you're in this study and you had been assigned to the grinders. You would give yourself and the grinders comparatively high favorability ratings, and you would give much lower ratings to the grounders. Those are the outgroup members, even though this group was entirely bogus, which is absolutely fascinating. What I thought was even more fascinating was in some of these trials, they would have the computer engage in another kind of manipulation. The computer, about half the way through, would ring and say, oops, based on your more recent responses, we think we had misassigned you. Originally, we thought you were a grinder. Now we think, based on your responses, that you're a grounder. Of course, this is all bogus, but That's what the computer told the respondent. And now the respondent proceeds through the remaining half of the questionnaire, assuming that he or she is now a grounder and not a grinder. And lo and behold, what you see is the social desirability effect now is being applied to the grounders and not to the grinders. The grounders are achieving the higher level of social desirability, the grinders the lower level, and this is a complete reversal from what we had earlier. So the point about all of this is that social desirability effects can be very powerful. They can be really quite arbitrary, but as soon as we believe ourselves to be inside of one group, social desirability tends to go up for that group. Really interesting experimental manipulation. A related effect is something called the outgroup homogeneity effect. And that is that most people tend to see members of social outgroups, that is, outgroups that are people who are in groups very dissimilar from their own groups, they see those outgroup members as being very similar to each other. Oh, they're all the same would be a characterization that we might offer to help us understand the homogeneity effect, the outgroup homogeneity effect. By contrast, when we're asked to reflect on each of our own in-group members, we tend to perhaps overestimate the amount of heterogeneity we have. We see ourselves as largely individuals with our own personalities, our own distinct traits and idiosyncrasies, and we're less inclined to afford that same consideration to outgroup members. Okay, so we have a couple of different interesting effects related to social cognition. Okay, let's see if we can now move on to some other issues in developing questionnaires, including issues relating to reliability. In prior lectures, we've talked about how reliability can be thought of as repeatability. We want our measures to be repeatable. We talked about the importance of replication in science in general, and the ability to replicate the findings that we have in any one study. So this is the issue, then, really of reliability. And what we might do when we're developing our questionnaires is ask about the reliability of the questionnaires that we've developed, and how would we go about establishing that empirically? How would we convince a skeptical, not cynical, but a skeptical reviewer that our instrument, our questionnaire, really did have reliability? Well, one of the methods that we're going to be talking about, and there will be two that are fairly similar to each other. The first of these is called the test-retest method. The same questionnaire is administered to the same large sample at two separate times. Time one would be the test, time two would be the retest. Reliability is indexed by the extent to which relative rankings of respondents remain stable from time one to time two, that is, across the test and the retest. Note, the overall scores on the second administration of the test may be higher or lower than the first. The critical factor is the relative rankings. Okay? And we'll draw a diagram that might help to clarify that in just a moment. We might ask ourselves, what statistic could we use to empirically empirically establish that our instrument has test-retest reliability? It might occur to you that based on the fact that we've just finished some conversation about correlations, that the statistic we're looking for here would be the R statistic. So what I'll do in just a moment is I'll draw a diagram on the board that shows how we might have a scatter plot and an R statistic to help us establish reliability via the test-retest method. Before I do that, though, I thought I'd just introduce a near cousin to the test-retest method. I mentioned that we'd have these two methods, and here's the second of the two. It works in a qualitatively similar way, slightly different in the details. The alternative would be something called the split-half method rather than the test-retest method. In the split-half method, we'll assume that we want to measure depression, and you have a 100-item questionnaire on that topic. The 100 items can be split in half, and we can do first half versus second half. We can do odd numbers versus even numbers. Any way that you want to divide that is fine. And the two halves could be separately scored for each respondent. Okay, so we're getting now two measures on each respondent, just like we did in the test-retest method, but now these are being taken all at one time. And if we have a sufficiently long questionnaire, this would work. We could divide odd versus even, or we could divide first half versus second half within the questionnaire. And if the tests were reliable, people who score high on one half should score high on the other half. Okay? So hopefully now you have some idea about how you would establish reliability in a persuasive and quantitative way. And we'll go back and look at test-retest and the split-half method when we're dealing with reliability. So let me close out of this. And we'll see if we can draw this on the board. We can use any number of traits that we might want to measure, any number of variables that we might want to measure. So let's see if we can get a scatter plot going. And in the example we used a moment ago, we talked about a depression questionnaire. We've talked about depression a lot. Why don't we go with some other example, just to give us a little bit of topical variety? Why don't we talk about something like a personality trait such as introversion? So we'll call this our introversion measure. And we'll assume that you and I are personality psychologists, and we're very interested in this topic of introversion. And we want to develop a questionnaire that we think assesses introversion versus, say, extroversion. And we have lots of different items. Maybe we have 10 items, or maybe we have 100 items. We can talk about the test-retest method. And what we would do is give the introversion scale to somebody at time 1, maybe the beginning of a semester. And then later on that semester, we give it again. And we would imagine that if personality traits are relatively stable over time, and if we have reliability, which is really the issue that we're testing here, that we should get pretty similar scores for a given individual at time 1 and time 2. So let's call this time 1. Let's call this time 2. And what we can say is that we'd have for any given respondent a score. We'll pretend here that maybe we're working on a scale that goes from 0 to 10. Our first respondent gets a relatively low introversion score at time 1. We'll call that a 1. They're very low on introversion. And then maybe they're low again the second time. They're down at around 3. Our next participant might have relatively high scores, maybe something like 9 and 10. So that would be a very introverted person. Somebody else has relatively intermediate scores, maybe 6 and 5. I think you get the idea. So what we can do is construct a scatter plot based on these observations. So if we take the 1 and the 3 at time 1 and time 2, that's going to be something like here-ish. Okay? 9 and 10 is going to be way up in this corner. 5 and 6 is going to be a little bit more intermediate. And you can imagine that we can fill in more and more of these. And if we fit the best fitting line or the best fitting trend, it might be something like that. So you would see then that the R value would be relevantly greater than 0. It probably wouldn't go all the way to 1, but let's just say that we had an R equaling 0.8. If that were the case, then we'd have some evidence suggesting that we had reliability. That is, from time 1 to time 2, we were getting largely the same kinds of scores. Okay? So this would be one of the ways of establishing test-retest reliability, taking advantage of the R statistic. It's intriguing that we had used the R statistic earlier to find the relationship between two variables. Now we can use the R statistic to establish the reliability of an instrument that you and I have constructed. So we can empirically demonstrate to a critical reviewer that we do have a test here that's measuring reliably some kind of construct. In this case, it's the construct of introversion. And we can offer a quantity like an R of 0.8 if, in fact, we get that kind of an R. So we can use the same sort of a questionnaire, but what we might do is administer it just at one time. And if we had lots and lots of items, we might say that we can look at the odd-numbered items. Okay, these become odd number. And this is even number. And we would fit the respective points. We'd find the best fitting line. We'd compute the R statistic associated with that. Again, that might be a Spearman R had these been rank orders. It might be something like a Pearson R if these had been on scale variables, which we know from SPSS would be something like a ratio scale or an interval scale. Right? And whether we're plotting the even or the odd, we would still see the function that's fitting there as being significantly greater than 0. Hopefully that would be the case. And now we'd be using the split half method, and we would establish reliability that way. So that's one of the ways that we can take advantage of the R statistic to show that we have reliability. Okay, let's now go back into our PowerPoint and move on to our next issue. And as you might imagine, as we've talked about before, reliability and validity are important issues. So let's see if we can now develop the validity of a questionnaire. And this is a bit trickier. Usually there's a little bit more room for argumentation on validity issues than there would be on reliability issues. You'll see, though, that there's also an important similarity in terms of using the R statistic to establish validity. So we might ask ourselves to think back to the history of psychology and ask about the early development of the IQ tests, which were established originally by Binet, and remind ourselves about what Binet was grappling with in the early part of the 20th century. Binet was very interested in helping children who were struggling a bit in school. And he thought that he could develop a questionnaire, as we'll call it today. It was really an IQ test. He hoped that his questionnaire/IQ test would help identify children who might be at risk for doing poorly in school. And that's really a very noble goal. He probably would not have envisioned at the time that about 100 years later, IQ tests and their near cousins would be used to stratify society into who goes to college and who doesn't, who gets into very elite colleges and who doesn't. His initial motivation was simply to identify kids who might be at risk and to help those kids. It's hard to imagine something more noble than that. Okay? So how did he think about the validity of his then new IQ test, his questionnaire, so to speak? Well, he reasoned this way, that he might get something that we contemporarily call convergent validity. Okay? Independent measures of a given construct are correlated. Okay? They independently converge on whatever it is they are measuring. So we can talk about measuring something like intelligence, is what an IQ test at least allegedly measures, and that would be our construct. And we can look for different measures of intelligence and see if they converge. And as you'll see in a moment, we'll take advantage of the R statistic to measure that convergence. So here's a subtle point. We can use correlations to inform us about validity, not just about reliability. So Binet, he's trying to look at the construct of intelligence. He's developing this IQ test. He's trying to figure out, does his new instrument, his questionnaire IQ test, have validity? So the way he begins to reason about this is, he says, well, if I were to get a rating from the various school teachers about who in their classroom learns really, really quickly and who learns less quickly, and maybe have the teachers rank order their students in terms of who learns the most quickly and who learns the most slowly, if my test is measuring what I think it's measuring, and that's the issue of validity, then we should have a nice convergence between my test and the teacher's rankings. Okay, so we would get convergent validity. Okay, let's see if we can draw a picture of that. I'll go out of here one more time. Okay, so we're Binet, and we're back 100 years or so, and we're trying to establish the validity of our new questionnaire, which is really going to take the form of an IQ test eventually. So we'll get the scatter plot going. And he's looking for his IQ test, that's what I'll call it here, to somehow converge with teachers' ratings of who learns quickly and who's learning more slowly. So we'll have teachers' ratings over here on the x-axis. Okay. And we'll say that this is the quick end and this is the slower end. Okay? So a particular teacher gives a particular student who's maybe the fastest student in the class a very high rating for how quickly that student learns. And then it might be the case, if Binet is lucky, that that corresponds with a relatively high IQ. It might be the case that teachers' ratings that are corresponding to the more slower learning students are going to be down here, and maybe the IQ scores are going to be down here too. And we might fill in some hypothetical points. You would imagine that this is not going to be a perfect fit to the best fitting line, but we might get a trend like that. We might fit an R. Again, this R might be, I don't know what it would be, I'll say 0.7, something greater than 0, but not all the way to 1. And to the extent that we get a strong R value here, we could say that we have convergent validity. Again, the notion that this measure of the construct of intelligence is converging with or corroborating this measure of that same construct called intelligence. And then he could do this a few different ways. We could say, independent of what the teacher's ratings are about who's learning quickly and who's learning slowly, we could go to last year's grades, and we could say, well, which of the kids scored the highest GPA last year? Okay. And now we can run a correlation with that, and that might again turn out to be something that's significantly greater than 0. It might be, though, of course, that we get a trend that really is much more circular. Maybe there's no correspondence between IQ and GPA. And we get more of a circular cloud of dots that has a best fitting line with a slope closer to 0. And here the R value would be either exactly 0 or nearly so. Okay? This would be evidence against convergent validity, and that would be a problem for our instrument, but that's something we want to know. We really do want to know scientifically whether we have convergent validity or not, and we can take advantage of the R statistic to show us that. Okay, let's go back into PowerPoint. And move on to the next concept. The next concept is probably one of the most subtle of the entire semester. So we're going to go through this one, and then we'll take just a little break after this so we can make sure that we haven't overwhelmed you. We're still on the topic of validity, but now we're going to introduce a new variety of validity, and this is called discriminant validity. So we're hoping to establish both convergent and discriminant validity. Let's define discriminant validity this way. The ability of a questionnaire designed to measure one concept to yield answers that are not correlated with those of another questionnaire that measures a similar but different concept. That's a very long definition. It's a very, very long definition. And sometimes students find that confusing, but also an example will typically help us to see that a little bit more clearly. We'll look at discriminant validity in terms of a construct called life satisfaction versus a similar but distinct construct called positive affect. And you might want to check this out if you want to cut and paste this into your browser. There's a very interesting PubMed abstract here. So in this particular case, let's pretend that we're trying to develop a questionnaire that's looking at this construct called life satisfaction. We would hope, on the one hand, that we could use test-retest methods to establish the reliability, not validity, but the reliability of that. Or we might use a split-half method to establish the reliability of our life satisfaction questionnaire. Okay? Then we might go on, as we did just a moment ago, and try to establish something about validity. We might look at the convergent validity, and we would see, for example, if life satisfaction converges, our measure of life satisfaction converges with other measures of life satisfaction. Maybe there's already existing questionnaires that have been validated, and we want to make sure that our measure is converging with their measure. That would give us convergent validity. But now we have this new idea of discriminant validity. How do we get there? How do we establish discriminant validity for our life satisfaction questionnaire? What we're going to do is introduce a construct that is similar but still distinct from life satisfaction, and that construct is positive affect. So you might think that life satisfaction is similar to positive affect, but it's not exactly the same thing. You can imagine somebody, for example, who doesn't have a lot of positive affect. Imagine that there's a relatively nasty workaholic. This is a person who grumbles a lot, not a very happy person, not a lot of positive affect. Yet this person still might self-report that they derive a lot of satisfaction from their work and that they believe it to be very satisfying. Okay? Their accomplishments very satisfying. They like to win, they like to achieve, but they're not particularly happy souls. Okay? So these are in fact distinct concepts. On the one hand, you can be satisfied and happy, you can be satisfied and grumpy. Generally speaking, I would guess that life satisfaction tends to co-vary with this, but we want to make sure that we will have a distinction between those two similar constructs. How would we do it? We would use discriminant validity, and here's how we would plot this. We're going to go to the R statistic one more time, okay? And we'll see how we do that on the board. Put this back up. We'll leave our scatter plot outline. Okay. And we'll now do something like this. We'll look for life satisfaction. We're getting some kind of responses from our questionnaire. And we might take some other known and reliable measure of the similar but distinct construct, something like positive affect, which I'll abbreviate here as PA, for positive affect. And we're hoping now that our questionnaire is distinct from that questionnaire. So what we would like to see ideally is that we, in a perfect world, we'd be able to get a cloud of dots such that no matter what the scores were on our life satisfaction questionnaire, there was no reliable correspondence with the positive affect questionnaire. We would hope to have an R equals 0 here to say that we're clearly discriminating. We're measuring something that is not related to positive affect. And this R equals 0 would be very strong evidence that these responses are not related to those. More realistically, it's probably not going to be R equals 0. If these are similar constructs, but distinct constructs, you're probably going to have some number that's slightly greater than 0, but not a very strong relationship. You might expect maybe something that looks a little bit more like this, a slight upward trend in all of this noise. Right? You might notice that that would be slightly greater than 0, and maybe this is going to be, I'll make up a number, 0.3. Okay? So to the extent that we get lowish R values here, then we have discriminated between these two similar but distinct constructs, and we're using the R value one more time to tell us about at least one type of validity. We might call this discriminant validity, and we're contrasting that with convergent validity. Okay? All right, so why don't we draw the line there just for the moment. We'll come back, but we'll see if you have questions that you've jotted down, and especially it would be interesting if you could generate your own kinds of questionnaire topic, your own construct, and see how you might establish convergent validity for that construct and discriminant validity. We'll give you a moment to do that, and we'll come back and see how you've done. Okay, welcome back. What we're going to do now is proceed with some other ideas relating to developing questionnaires, and we'll offer you some tips for good questionnaire items. So what we might start out with is keeping the vocabulary simple. Many of you who are tuned into this are college students, and you would probably not be aware of the fact that your vocabulary is likely to be much greater than those of typical folks from around the country who have not had the benefit of the educational experiences that you've had. It might be the case that because you're immersed in an environment where you're learning new vocabulary all the time, and perhaps you're really good at learning new vocabulary, you might be a little bit different from a much broader population that might not have the same vocabulary that you have. It might also be that you are learning in a language that is your native language, and other folks from around the world will be having, for example, English as their second language, and understandably their vocabulary would be smaller than yours, just as my vocabulary in my non-native tongue would be much smaller than that for my native tongue. So we might want to keep the vocabulary very simple so that we can be as inclusive as possible in our questionnaire. The item should be clear and specific. No leading, loaded, or double-barreled items. So let's see if we can give you an example of a double-barreled item and why that would be problematic. One particular double-barreled item might be something like this. In the last 6 weeks, have you experienced sleeplessness or anxiety? Okay? Sleeplessness or anxiety. Those are actually two different ideas, and let's say that somebody says yes to that. Well, that could mean that they experienced sleeplessness, or that they experienced anxiety, or that they experienced both. And it might very much be the case that you and I will need to distinguish between whether sleeplessness is predicting or whether anxiety is predicting. And yet if we put those two as a double-barreled item onto one particular question in our questionnaire, then we'd have no way of disambiguating those, and we don't really know what's driving the effect that we might want to see. So it would be better to separate those out and have one item on sleeplessness and one item on anxiety. We don't want to put those together, or we'll never be able to disentangle them once we come to the data analysis phase. It's best if we keep the items brief, less than 20 words. That also tends to increase the clarity. Okay, a couple of other tips for good questionnaires. Present all conditional information prior to the key idea. You might recall from earlier sessions that when we're talking about conditionals, we're making at least an implicit reference to the word if. Okay, so if this, then that. The if component is going to be our conditional component. Okay? So let's see if we can give you an example of a proper way to construct this and a less desirable way to construct this. So remember, present all conditional information prior to the key idea. If money were not an issue, what would you study in college? So here's the conditional information. If money were not an issue, comma, what would you study in college? That's really what we want to know. What would you study in college? And we're trying to prompt them for an answer about what they would study in college. So we put the conditional information first. Here's where we could get ourselves into trouble. Here's an example that's not as good. What would you study in college, comma, if money were not an issue? Frequently, respondents will pick up on the most recent information, if money were not an issue, and they might begin to go into all kinds of possibilities like, oh, if money were not an issue, I would buy a boat. I would buy a yacht. I would buy a mansion. I would take this trip. We don't really want to know what they would do with money in general. We want to know specifically what would they study in college. We could wind up distracting our respondent if we put the conditional information last. So people who run questionnaires on a regular basis have come to the conclusion it's best that if you do have conditional information, then you should make that before the primary idea. Okay. We also want to see if we can detect response biases by using oppositely worded items. So we've mentioned before that we have different kinds of biases on our, people typically have different kinds of biases when they're responding to questionnaires. They might have a central tendency bias. They might have a social desirability bias. Sometimes people are just inclined to make their way in and out of a survey situation as quickly as possible. And they want to receive credit, for example, from a Psych 100 class or an Introduction to Psychology class, and just by going in, filling out the questionnaire, and getting out. And what they might do is just circle 5s all the way down on a 5-point scale. Or they will circle 1s all the way down just to get out of it. Okay? So how do you guard against that? How do you know whether somebody is giving you a bunch of 5s because 5 really is their best opinion or best represents their opinion, or whether they're just going through in a very superfluous manner and trying to get out quickly? Well, one of the ways to detect that kind of responding is to use oppositely worded questions. So for example, you might want to know something about emotions, and you might want to have a questionnaire, an item, that says something like, I often feel anxious. Okay? And it might be something like strongly disagree to strongly agree. Okay? So we're going from disagree to agree here, and so a 5 would mean that we strongly agree with the statement, I often feel anxious. At some later point in the questionnaire, we might have a separate item that has opposite wording, but the same kind of a scale. So we might now say, I rarely feel anxious. Okay? If they give you a 5 here and a 5 here, that would suggest that they're responding superfluously, that they're just giving you very superficial kinds of responses, and they're circling 5s maybe all the time. Because it would seem incoherent to say that I often feel anxious and I rarely feel anxious. Those are contradictory statements. Hopefully, we would get people who would respond at opposite extremes here, and that would be an indication that they really are reading the item, they understand what it means, and they're responding coherently. It's difficult to detect that for sure, but by using oppositely worded items, words that are antonyms, for example, we can begin to gain some insight as to the truthfulness of the respondents' responses. Okay, we also want to test for readability. We want to make sure that things that you and your research partners believe to be clear really are clear to those who are taking the test. And so this brings us to our mantra for today, and that is pre-testing is critical. Can you say it with me? Here we go. Pre-testing is critical. So after you've developed your questionnaires and you've thought about keeping things brief, less than 20 words, no double-barreled questions, all conditional information is coming first, we have some oppositely worded items so that we can get rid of these bogus responses that some people would give us. We want to make sure that we have a nice and readable questionnaire, and so we might run it on a sample of folks before we put it out to a much larger group so that we make most efficient use of our time. Okay, something else we should say is that the order of the questions matters very much, and this is sometimes something that's difficult to know in advance, but it is something that we might think about. If you're running a computer-based experiment, one of the nice things is computers will sometimes allow you to randomize the order of the questions so that you don't get any systematic sequencing effects or order effects. Okay? So here's an example that you might find really interesting. This is a famous example by Schumann, Presser, and Ludwig from 1981. And it goes like this. They were asking questions about abortion-related issues. And one of their questions was, do you think it should be possible for a pregnant woman to obtain a legal abortion if she is married and does not want more children? Okay? That would be the question that was posed to the respondents. And what was very interesting was 60.7% agreed with this statement when this question preceded another question on abortion. Okay? By contrast, when they reversed the order and they had this other question on abortion preceding this question, which is worded exactly as it is here, that number dropped to 48.1% agreeing when it followed that other item. Okay? So just by changing the sequence, we got different response rates. And the only point about this for our purposes is that the sequence does matter. So you might want to think very carefully about how to order your questions. And if you are doing this by way of computer, you might realize that there can be some benefit in randomizing the order. That wouldn't necessarily mean that the order effect goes away for any given individual, but it would go away for your sample. That is, some of the students would be receiving this question, this kind of question first, others would be receiving it second, and that might be the fairest way to sequence your questions. Okay, here's another issue that you might remember reading about, and this is the issue of filter questions. Okay? So what are filter questions and what is their value? We'll give you a moment to stop the video and respond to that. Okay, welcome back. Why don't we go on? And we'll now address some issues relating to the interpretation of the information that we get out of our questionnaire. Right? This issue is very important. Reported versus actual behavior. It's not as congruent as we might like. As we said when we began our conversation about survey research methods, there is an ongoing question about the extent to which surveys and self-reports really do reflect the extent to which people would behave. Okay? Now, of course, surveys have other benefits too. Surveys tell us about attitudes, and attitudes are a very important part of psychology. But there's this question about self-report and actual behavior. That is a legitimate question. Here's something that I think you might find especially interesting. People self-report that they would help someone in need regardless of bystanders. Behaviorally, though, you and I might recall from Intro to Psych, the bystander effect replicates very reliably. And this is something that had been shown quite famously by Latente and Darley in 1970. We can ask folks if they would help somebody who is in need, and they would say yes. And then we can say, well, suppose there was a bystander, would you still help? And they would say yes. Suppose there were 2 or 3 or 4 bystanders. They still say yes. But when you actually run experiments where you have a bystander and maybe increasing numbers of bystanders, the probability of having a given person help out actually goes down, and this is a very reliable and very repeatable kind of effect. So what people are saying and what they're doing tend to be less congruent than you and I might like. So it's something to think about. Okay? So what this suggests is that we might want to use a multi-method approach. We might want to get some survey data, but we might also want to look at actual behavior, and some combination of these varied methods might give us the best insight into the construct of the phenomena that we choose to investigate. Okay, let's see if we can go on now and understand a little bit more about the interpretation problems associated with really any kind of research, but in our particular case, we're talking about questionnaires. Okay, so how do we interpret the correlations that we might find? We know from Intro to Psych that correlation does not imply causation. Okay, we know that to be true. We might ask why correlation does not imply causation, and there are at least 2 broad categories that we can think about. One issue is this, the spurious correlation, third variables. Okay? Another issue that we'll come back to in a moment is that the direction of causation is often ambiguous. Okay, let's take this first one. That brings us back to one of the founding mantras of Intro to Psych, and that is that correlation does not imply causation. So this is said because of the quote-unquote third variable problem. Let's see if we can give you an example about third variables. I'll use something that's really quite straightforward and I think quite obvious. You might know that there is an association between the number of murders in a city and the number of traffic lights in that city. As the number of traffic lights goes up, the number of murders in that city also tends to go up. Okay? It would be, though, very unlikely that the number of traffic lights is causing the number of murders. Right? It's probably not the case. There might be some third variable. And we can ask ourselves, well, what is that third variable, or what might it be? And as you might guess, a plausible third variable in this case would be something like the population size. If we think of a very small town, like the small town of Granville, Ohio, where Denison University is, we can say that we have a relatively small population, and because we have a small population, we don't have that many traffic lights. And because we have a small population, we don't have that many murders when we count the number of murders in a given year or a given 10-year period. If we contrast that with a much larger city, like New York City, where there might be several million people living, it's not surprising that because we have several million people living in New York City. We have many, many more traffic lights in New York than we would in Granville. And correspondingly, we have many more murders. Even if the murder rate were identical, we're taking that percentage off of two very different base populations. So clearly the size of the city in terms of its population is a third variable that might be explaining the relationship between the number of murders and the number of traffic lights. This is a third variable example. Okay? And this is one of the reasons why we'd say that the correlation between the number of traffic lights and the number of murders is maybe a spurious correlation. It might be measurable. We might get a strong R value, but it doesn't mean that there's a causal relationship between those two. Okay, let's go on to another possibility that we should consider, and that is that sometimes, for some correlations, even though they might be very strong, the direction of causation might be ambiguous. And we've considered one of these examples before in our video series. Let's give you a different example, and one that's very relevant to something that a lot of students are interested in. A lot of students have an interest in clinical psychology issues, and many of us have an interest in the autistic spectrum. So what we can say about that is that it was thought early on, maybe a few decades back, that we didn't really know what kinds of factors put a child onto the autistic spectrum. And there was some consideration that it might be the case that children land on the autistic spectrum perhaps because of the way the parents are acting toward the child. For example, it might be the case that parents tended to make less eye contact with their children who are on the autistic spectrum than they did with their children who were not on the autistic spectrum, the more typically developing child. Okay? So maybe parental eye contact was one of these factors. Okay? Now here we can do a series of studies and we might be able to show that there is in fact a strong correlation between parental eye contact, how frequently that's happening with a child on the autistic spectrum versus children who are not on the autistic spectrum. There might be an association between those variables. But the direction of causation might be ambiguous. On the one hand, it's possible that a lack of eye contact is causing a child to be on the autistic spectrum. Okay? At least back several decades ago, that was one possibility that people were thinking about. Of course, the reverse is also possible. It might be the case that because the child is on the autistic spectrum, there's something about those symptoms that makes the child perhaps less engaging to the parent. And so it's the child's autistic symptoms that are driving relatively low parental eye contact. Okay? So the direction of causation is ambiguous. Just to be absolutely clear, now no contemporary researcher believes that there's a causal relationship between those two. Nobody is suggesting that children are on the autistic spectrum because parents are failing to make eye contact, but that was something that people considered many decades back in psychology's earlier history. Again, it's a nice example of having an ambiguous direction of causation. Okay, so given that we have these potential third variables, we might say, is there any way to unpack that, to disambiguate the third variables? And some method that we have for doing that is called the path analysis. Okay? So this will help us look at some potential causes in a very systematic way. And we're going to, one more time, take advantage of the R statistic, the correlational statistics, that we had developed in previous videos. Okay, so let's take a look at the path analysis, a statistical technique that can help clarify the interpretation of correlations, particularly with respect to these third variable possibilities. And we're going to introduce two terms, one of which we'll really focus on today, called the mediator, and one of which we will define today and come back to later on in the semester when we're understanding factorial designs and something called an interaction effect. The mediator is defined this way: a variable that is used to explain the correlation between two variables. Okay? And we can define a moderator as a variable that affects the strength and or direction of the correlation between two variables. And again, this will be pertaining to something called an interaction effect that we will get to later in the semester when we're talking about factorial designs. Let's see if we can jump in and understand by way of picture how the mediator might look. Okay? Let's say that you and I are really interested in this independent variable, which we call a predictor, typically plotted on our x-axis on a scatter plot, and we're interested in how that relates to our dependent variable or criterion, which is plotted on the y-axis or our ordinate. Okay? And we're showing that maybe we have a strong relationship there. We could actually take a Pearson or a Spearman R, and we can find what that relationship is. We can then introduce a potential third variable, which we have up here. We'll call that generically our mediator, and we'll look at the relationship between the IV and that variable, and we'll get a Pearson or Spearman correlation going on there. And finally, we'll get one more pairwise correlation between the mediator and our outcome variable, or our criterion variable. So we'll have now 3 R values that are going to be helping us in this path analysis. This is very generic. Let's see if we can take 2 different examples to help drive this point home. Let's say that you and I are interested in the relationship between SAT scores and college GPA, academic performance in college. You can imagine that every college's admissions office is very interested in this relationship. We want to bring students on campus who we think will succeed. It would be unfair to the student to bring them on campus if we have some reason to believe that they couldn't succeed here. We want our students to be successful. So we're really interested in this, okay? And we're wondering, is SAT a good predictor of this? And we can use an R value to tell us something about that correlation. We get an R value here. Then somebody might say, well, you know, it's not really SAT score. It's this other third variable, which is socioeconomic status. So we can find a relationship here by correlating the two, maybe with a Pearson statistic. We can find a Pearson statistic, the R, one more time between SES and college GPA. Okay? And we can see if this relationship holds after controlling or factoring out the SES. Okay? See if we can do another example that we might have. Let's say that we're looking at psychological distress as our psychological variable of interest. And we're wondering to what extent that covaries with poverty, maybe even caused by poverty. So we can get some kind of index of poverty, some index of psychological distress, and we can correlate that. We can get correlations between poverty and some operationalization of chaos. We'll get that correlation, and then we'll take the chaos operationalization and we'll correlate that with psychological distress. And now, once again, we have a trio of R values. Okay. So assume that poverty, our predictor, correlates significantly with psychological distress. There is a correlation along our bottom row in that big triangle that we were just looking at. Right? We'll say that's a significant correlation down here. Is that correlation mediated or explained by chaos? This is what we might ask. Yes, if the data pass this so-called mediational test. It's an interesting test. Predictor and mediator are significantly correlated. Okay? That's going to be the variable over here and the variable up here in our preceding diagram. Criterion and mediator are significantly correlated. Okay, so the mediator is up here. Our criterion is over on this side. Okay, and the predictor and criterion correlation is significantly reduced after controlling for the mediator. So if we pull out this effect, then we can say that if we have this go all the way down to 0 as our R value, or nearly so, then this variable up here, our third variable, might have been mediating that relationship. Okay, so let's see if we can draw that on the board, just to make sure it's really clear, and we'll give it to you in a slightly different format. We'll give it to you by way of Venn diagram. Lots of students find Venn diagrams to be intuitive. So what we can say is that we're interested in psychological distress. As psychologists, that's what we're trying to predict. We initially think about poverty as a strong predictor, and we have a R value that's showing the relationship between those two. Then we think, well, maybe it's not really poverty. Maybe poverty tends to be associated with a certain amount of environmental chaos, of environmental disorder. So can we somehow operationalize chaos, get a measure of it, and see how it lands on this Venn diagram? It might be, very hypothetically, that chaos would have some overlap that looks something like this. Okay? And I'll put chaos over here. What's interesting is then there's a lot of overlap across all 3 of these, and what remains after having removed statistically by path analysis the effect of chaos, we only have a smaller amount, which I'll draw in green, of overlap between poverty and psychological distress, and that might even be a non-significant amount of overlap, a non-significant correlation. So if we factor out the overlap attributable to chaos, and we significantly reduce this relationship, we might then say that chaos was significantly mediating the relationship between these 2 variables, and sometimes researchers go as far as saying that chaos was explaining the relationship between those 2 variables. Okay? So that's a lot, but then survey research is very complicated. What I hope you'll do now is reflect on what we've talked about so far, make a note of what was clear and what was not so clear, and bring that information into class. See you in class.